Now, normally, if you have a game running off of your SSD, this also happens to be where our Windows is installed, and you were to simply unplug the SSD from the computer, we'll also go ahead and remove it from power just like that. You might notice that we can in fact move our cursor around, but we can't interact with any of the windows. And over time, well, we even lose access to our mouse control. Eventually, we black screen and blue screen. But today, we're going to attempt to beat an entire video game without the use of an SSD. Now, while this might seem impossible, we first need to understand how the different components of a computer communicate with one another. Because the CPU, the brains of the operation here, does not actually directly communicate with any storage that's plugged into the computer. Our SSD, of course, is where Windows and our game files are all installed. However, when we end up launching those games or running Windows, the computer pulls the data from the SSD and moves it over to RAM, the random access memory. So the RAM is actually where the game is being played from, not the SSD itself. Hypothetically, the more RAM we add to our system, the longer it'll keep working after we remove the SSD. And right now it looks like we have 16 gigs of memory in this system. So let's double that. This is typically just my test bench, so I only have a single stick of DDR4. And so ideally we find the exact same make and model inside of our RAM box here. So like, here we go. This is a DDR4, what is going on here? Oh yeah, I had made a RAM bling necklace. You know, because the rising prices of RAM these days, instead of like a gold chain, you could just have a RAM chain, you know? But this is the stick of RAM that I need to use, so we need to undo this necklace. This will add 16 more gigs into our system to a total of 32. And will also let us take advantage of dual channel memory. And okay, to verify, we do now in fact have 32 gigs inside of our system. So now let's see how long we can run this game for after unplugging our SSD. Hypothetically, it should be for longer, because more data can be stored inside of our RAM. But let's see what actually happens. Just like last time, we will remove our SSD from the computer as well as from power. But despite that, we can actually still play this game, even though our computer has no storage currently attached to it, which is actually kind of absurd, right? This feels like a very normal gaming experience. So even though we can play the game now, the true test comes when we try to move on to the next level. So let's go ahead and give that a shot right now. Uh-oh, and it looks like our computer froze yet again. Oh, okay. There we go. Diving a little deeper into how our computer handles the video game, that first level is being loaded from our SSD into our RAM. And then our CPU is able to communicate in that level, which is why we are able to play without the SSD. However, as soon as we trigger something that is not currently stored in RAM, such as the second level, we need to pull that from the SSD. But when the computer can't find this because it's not plugged in, that's when it crashes. So now the question is, even with 32 gigs of RAM, how do we run an entire game without an SSD? Now to figure out exactly how to do this, it would be incredibly helpful for me to chat directly with my prior research regarding manually loading data into RAM, but all my past notes here are scattered across Notion, Google Docs, Slack, you name it. Thankfully, today's video sponsor Zapier has helped me bridge the connection between my research and my LLMs, giving me a secure way to provide Claude access to my various notes apps. With Zapier MCP set up, now I can directly ask Claude in plain English to pull together all of my past research surrounding RAM disks from Notion, Docs, and Slack, and it'll fetch all that information without me ever having to switch apps manually. And from here, conducting further research is even more seamless now that my chats have access to my past research for additional context. And importantly, with Zapier MCP connected, now I can also ask Claude to generate new notes back into my apps of choice, further letting me stay more organized by saving my new findings in my preferred notes tools, as opposed to those insights being buried in some past chat history. The setup for this is also incredibly straightforward. Honestly, most of it is just pasting a command into Claude and then enabling a toggle or two in Zapier. Plus, there are over 9,000 apps that you can connect via the Model Context Protocol for whatever use cases you have in mind. So if you would like to learn more and start building super customized MCP integrations with Zapier, I'll go ahead and leave some additional information down below. But now let's get back to playing a video game entirely from RAM. And so the next thing we're gonna try is moving the entire game file with every level from our SSD into memory. But to do that, we need to enact a few specific steps. We essentially need to make a drive partition on our RAM, which is essentially like treating our RAM like a hard drive or SSD. The main difference being, once the computer shuts down, RAM is volatile, so all of that entire drive will go away. But if we make the partition big enough to store the entire game folder for Super Meat Boy, we don't really care if it goes away once the computer turns off, because our goal is to be able to play it before the computer shuts off to begin with. So to do this, I'm going to use a tool called IMDisk, and this tool allows us to configure a RAM disk, which is exactly what we're looking for. And once that's set up, you can now see this RAM disk is accessible inside of our devices and drives, just like a hard drive or SSD would be. But remember, all of this is stored directly on our RAM. Now, importantly, on here, we also saved the entirety of the Super Meat Boy game file. And if we launch the game, not only does it load noticeably faster than pulling it from the SSD, well, now this entire game is running from RAM. So now let's see what happens if we remove our SSD from this computer. Third time's a charm, right? Now, I actually don't know if this is gonna work or not, so I'm extremely curious. But okay, if we remove our SSD from the computer and from power, just like last time, now we can continue playing our game as normal, but if we go to load the second level, well, can we actually get there? Oh my gosh, we can. Holy cow. Guys, this computer is working without an SSD, and we just switched levels in a game. Okay, let's see how far we can get. All right, we beat level 2. Can we move on to 3? We can. Oh my gosh. Oh wait, I forgot how to play this game. Whoa, oh no. Okay, it looks like Windows still decided to crash on the backside, which is interesting because we black screened, but the game is still up. That is kind of fascinating. Whoa, and now we flip-flopped. What is happening? That is really strange. We do still have access to our cursor as well. Oh, okay, we lost the game, interesting. And there we go, we blue screened. At this point, I have to assume that Windows is doing something in the background that requires pulling something from the SSD, and when the SSD is unplugged, again, that's when it crashes. Because it did not appear that our game was causing the crash. We were able to go through multiple levels with no issue. So either we need to figure out a way to prevent Windows from trying to do new stuff while we're gaming, and thus prevent it from trying to access the SSD and crashing, or we need to try to speedrun the game as fast as possible before it black screens. Let's try the latter. All right, let's see how far we can speedrun Super Meat Boy before our computer inevitably crashes. So we'll go ahead and remove our SSD, just like before. And now let's just get into it, shall we? Level 1, complete. Nice. Do some wall jumps. All right, level 2, complete. Now for level 3. Sprint, jump, let's get there, nice. Okay, we're still cooking, Now it has been a minute since I played this game, so excuse my my lack thereof skill. Oh, there we go. Level 4 complete. Okay, so as you can see, the limit itself is definitely Windows-based. Like the game loading new levels was definitely not the issue. So we're gonna have to figure out a slightly different way to go about this because I really wanna play video games directly from my RAM without any SSD plugged in. And unless someone can beat Super Meat Boy in like, I don't know, what was that, like 5 minutes? I don't think this is gonna be a viable option. And so if our operating system trying to pull from our SSD is the issue, what happens if we load our operating system directly onto the RAM as well? I kind of feel like this is opening a can of worms, but yeah, let's try it. Let's figure this out. I'm gonna try to download a lighter weight operating system like Ubuntu onto a USB drive, and then make the USB drive bootable and attempt to boot that into RAM. We'll certainly see if that works. Actually, let me see if I can format it on my laptop over here. Erasing everything on the drive, that's fine. Ooh, okay, I think it actually worked. Although this step might take a while. All right, we'll wait, we'll be patient. Okay, it looks like it did finally finish creating our bootable drive, so now we have this Ubuntu USB. But crucially, we do now need to make a new file on the root directory in order to save our game files so we can actually play something. And this is the part that I'm not actually sure will work or not, but we're gonna give it a shot. And then we're just gonna see if we can copy and paste like all of our Super Meat Boy game files into here. I feel like it shouldn't be quite that simple, plus the fact that we're trying to run like a Windows downloaded game on Ubuntu, which is a different operating system. We'll see how that goes. Okay, so with those files there, let's eject Ubuntu. All right, there we go. And now, hypothetically, this USB is the solution to all of our problems. So if we go ahead and plug this into our computer here, we're gonna try to have the computer boot from this drive as opposed to our existing SSD, which we will just go ahead and remove. Will this work? We'll see. Go ahead and boot up the PC. Now it doesn't have Windows to load from over here, so it's gonna have to pull from the next bootable drive, which should be this. Okay, so we have the option to boot into Ubuntu, but we do need to make sure that it loads into RAM. So inside of this line right here, we are simply going to add to RAM. Without that line, we're just gonna be running it from the USB, which is gonna be incredibly slow. So we actually wanna move all the information over to our RAM. Oh, okay, well that's not what you wanna see. AMD GPU failed, error -22. This is probably fine. It's probably fine, right? Turns out we might actually have to use the integrated graphics in our CPU if our GPU is not going to play nicely with this operating system.
One eternity later.
Okay, I was having a ton of issues trying to get Ubuntu to work the way that I wanted it to. So instead Instead, we're gonna go with a more lightweight kernel. We're gonna go with an anti-X approach. That right now we are trying to copy all of our Linux files to RAM. So once that's completed, this entire operating system, again, should ideally be right here because once again, our SSD is not installed at all. All right, but let's see how this comes together. Fourth time's the charm? I don't even know what we're at this point. Okay, hey, look at that. We got a GUI. All right, already this is much faster than what I was dealing with Ubuntu. All right, we still have some work ahead of us though. Because as of right now, while our operating system might be entirely in RAM, our game files are still on our USBs. So now we need to figure out a way to get those also into our volatile memory. I've never used this operating system before, but this default background reminds me of that starting room in Portal where like you're inside of that glass box. All right, so that's the game's current file location. Let's go ahead and move it into memory. This should copy the content of our game file over to a temporary RAM folder. And it is around like 500 megabytes worth of data. So you can see here that our disk has kicked into action, which is a good sign, even though it looks like it's doing nothing. Oh, okay, there we go. So now with our game files moved into RAM, we should be able to CD into that folder. And if we do that, we can ls to see. Yeah, okay, now we have RAM game right there. So now if we CD into RAM game, there's Super Meat Boy. Let's CD into that. Where's the game? Okay, and here's the EXE. So now it's actually the moment of truth. Can we run this game entirely from RAM? We're about to find out. I'm either gonna be really happy or really sad, one of the two. So now we can simply type wine and then supermeatboy.exe. And then we press enter. Okay. I'm seeing some errors, but wait. No, it encountered a serious error. They're sorry for the inconvenience. Now, what happened? All right, let's see. Show details. This means nothing to me, I'll be honest. All right, we're just gonna install some more packages and some drivers. I think maybe part of the issue was it wasn't able to render the game properly, so it failed. So we needed to install some Vulkan drivers. I don't really know, let's go ahead and give that a shot again. Oh my God, we actually got it working. Holy sh, oh my God, the game's running. The game is running. No way. Although every time we click into it, it loads. So if we Alt-Tab to a different window with Super Meat Boy not selected, we can see it running in the background. But as soon as I click on it, it freezes. If I go back, now you can see it moving again. That's very strange. So we can't really play the game, although we can load it in memory. Why is that happening? Oh, wait, I'm playing it. I'm playing the game. I'm playing the game. Okay. Dude, there's no way this actually works. It's loading. It's loading. Okay. Let's go ahead and see how far we can get. We're actually playing the game. No way. Oh my gosh. This is bonkers. However, we still need to do the actual moment of truth because right now we still have our USB stick plugged into our computer. So the real test to see if this game is actually running directly from our RAM with no storage attached is to remove this drive and hope this doesn't freeze. And I'm really nervous because if this doesn't work, we'll have lost a lot of time and effort. But I guess it's time to find out. All right, let's go. Removing the USB from our computer. The computer's still working. Can we still play? We are still playing. We are still playing the game. Oh my gosh. Run, little meat boy, run. Dude, this is actually absurd. Check it out, check out our computer. We have no storage attached to this whatsoever. There is no flash drive attached besides, our mouse and keyboard. That's what these two guys are right here. There is no SSD, there is no hard drive, there's no NVMEs. All we have is our RAM, and it's running our entire video game, which means that now we just get to see how far we can get into Super Meat Boy, because I don't think this is gonna crash. Fingers crossed. Oh my God, I'm actually so excited that this works. This is actually a first for me. I have never built a computer that can actually run with no storage attached to it whatsoever. Not only is our entire operating system running off of our RAM, we can even play an entire video game from our RAM as well. And because of that, our game is actually very snappy, right? Like there are 0 calls to an SSD to slow it down. Every time a new level loads, boom, it's already in RAM. Every time a new menu opens up, boom, it's already in RAM. There's essentially no loading whatsoever, which is awesome. And I honestly can't believe it works. Now I just wish I was a little better at this game. Let's go, another level in the books. To be fair, that was a lot of work, and we also had to completely get rid of our GPU because driver issues and what have you. So the fact that this computer entirely consists of RAM, a motherboard, CPU, that's it. I guess a power supply as well. It's really weird how if you click on the game, it freezes, but if you Alt Tab and then just Alt Tab back, you can control it. So, I don't exactly know what's going on there. It very well could be something to do with like the jankiness of how we set this up. but I'm fine with it. As long as it works, I don't even care, man. Okay, let's go. So whereas before with Windows, even with 32 gigs of RAM, we were still basically on like a timer, because eventually Windows would try to access something in the background to our SSD, which doesn't exist, and it would crash. But right now, we don't have to deal with that. So is it possible to beat an entire video game directly in your RAM? Yes, it is. So to summarize what exactly we did in order to achieve an entire operating system in game running without any storage in our computer, we first needed to download a lightweight Linux distribution. So we needed to get the actual ISO for that distribution. We then took a blank USB, plugged it into our computer, and then used a tool called Rufus in order to make this drive bootable, specifically with the ISO that we just downloaded. And then we also copied over all of our Super Meat Boy game files onto the root directory of this USB as well, after it was made bootable. So then we could take this bootable USB and plug it into our test bench here that doesn't have any storage, and then we could boot from it. Importantly, we needed to remember to add the to RAM command when loading the operating system, which then transferred the entire operating system to our RAM, which was also important to have enough space. So we had like 32 gigs of RAM. We definitely did not use even close to that much, but we also used like a pretty small game. This game was like 500 megabytes total. We needed to make sure that we downloaded and installed Wine. In this part, there was a lot more dependencies than I would have thought. And so whenever an error popped up, I basically just like Googled that library and then, installed it with sudo apt-get. But the final crucial step was to find the game files that were saved on the root directory of our USB and move those into RAM as well. And doing that is kind of dependent on what operating system you choose to go with. But in all of them, there should be a way to make like a temporary folder inside of RAM. And after all the game files were moved over into that temporary folder, we could go into that folder and launch the game with Wine. And then deal with like a lot more errors. But once you solve all those errors by downloading the different dependencies or libraries or what have you, eventually the game should run, and you should be able to completely remove the USB that had all this information to begin with, leading us to a game that is running with no storage attached to our computer, which honestly, it's a lot of work. And doesn't really do anything for you, besides the fact that when the computer shuts off, you lose all your game progress and have to reload your operating system from scratch. That's a benefit, But with that, I've been Mr. Yeaster, your tech tinkerer. Thank you so much for following along. This one was pretty fun. But with that, I will catch you in the next one. Aw, yeah.